You. So good afternoon, everyone. First of all, I would like to thank the organizers for allowing me to present to you this work. So what I am going to present you is the work of Master 2 of Katell Alaime, whom was supposed to do this talk, but unfortunately she was not available today. So I'm going to present you her master work and in the following of her work, my thesis project that I started recently last autumn. So this work is co-supervised by Fabrice Bray, Veerle, Patrick Auguste, and Marie-Pauline Julien, and is part of the ANR Big Game. So this project aims to study the relationship between neonatal population and large fauna in the northern plains of France during the entire Middle Paleolithic. So among other objectives, this project aims to study the subsistence strategies and to highlight so-called cultural phenomena among this neonatal population. So to enter these problematics, we choose to focus our study on bone tool studies using different approaches in addition to more classical methods, so proteomics, traceology, and experimental work. And this is the methodology I will present you today. So to begin with, what is bone industry? So to give you a general definition, it's any prepared bone object or teeth, antlers, or ivory that bears human marks of use that are not directly related to the processing of carcasses. So for the Middle Paleolithic, most of the tools that we know are retouchers. So retouchers are bone tools that owe their name to their use in the retouch of lithic tools, mainly to sharpen the edges. These retouchers bears really characteristic marks, as you can see there, that are print patches really characteristic. So even though these kind of tools are often considered very simple, they can give us useful information concerning neonatal behaviors. In fact, recent studies show a large variability and cognitive abilities related to the making and the use of such tools that highlight the cognitive capabilities of these neonatal populations. So while studying retouchers, we are facing several issues. First of all, most of them are diaphyseal fragments that makes difficult the identification of taxonomical identification. However, knowing the raw material is useful information regarding an intentionality or not in the choice of such raw material. In addition to this issue, most of our material is very ancient and poorly preserved, and there's a lot of stigmata that are really difficult to read. So most of the time, the real use of these tools is not really clear. So to overcome these problems, we're using different approaches. So paleoproteomics, archaeology, traceology, taphonomy, and experimentation. And I am going to present you this methodology now. So starting with paleoproteomics. So without going into too much details, paleoproteomics is the study of proteins contained in bone collagen by sampling a small amount of bone powder that is processed by mass spectrometry, and that allows us to have the profile of the peptides that are unique for each taxa. So it's a bit like paleogenetics, but with a better and longer preservation of the protein's through time. So for this study, we're using two different methodologies and techniques. So the first one is the zooarchaeology mass spectrometry, which is the most common. It allows us to have the profile of the peptides and so to identify our samples to the rank of the genus or the family. Another technique that we're using is the tandem mass spectrometry. It's a little bit more complicated to implement, but it allows us to have the exact amino acid sequence of our samples and so to identify to the rank of the species. It's also a useful technique that can allow us to understand extinct species sequences and so to do phylogenetic work. So for this project, we choose to use these two techniques because most of our samples lack of proteins, and so it makes our results stronger. So once the raw material is better identified, we can focus on the characterization on surface stigmata. So as you can see in this tool, in this retoucher, most of our material bears a lot of stigmata that are superposed, and it makes the reading really difficult. So to understand the making, the use, and to distinguish it from the genetic modification. That's why we choose to implement an experimentation work that Katell started last year during a Master 2 internship at the Liège University. And they were able to reproduce the printed patches characteristic to retouchers. So to present you the assemblage that we are working on, it's from the site of Biache-St-Vaast, which is located in the North Pas-de-Calais, in the northern part of France. It was excavated during the 70s, during one of the first rescue excavations that occurred in France. And despite the rapidity of the operation, more than 200,000 faunal remains were recovered, as well as 2 Neanderthal skulls. So it makes it a really interesting site, especially for level 2. It's really well preserved, thanks to fluvial deposits. And the faunal assemblage from this level where other retouchers come from is associated with Moustrian industry and was dated from MIS7. All the assemblage, the faunal assemblage was studied by Patrick Auguste during his thesis, and he identified the hunting, scavenging, and processing of carcasses on the site of Biache-St-Vaast, with a domination of the assemblage of very large prey, so auroch, brown bear, and rhinoceros, which induced a great coordination among the Neanderthal groups. His work also allows to identify more than 300 retouchers. That makes it one of the largest known retoucher assemblage for the Middle Paleolithic in Western Europe. And until now, no detailed study had been done on this retoucher assemblage. That's why we choose to focus and to start our work on this assemblage. So to present to you the results of Katell work, she studied only 10 retouchers, but she was able to highlight taxonomical differences in the attributions. So for example, for this retoucher, the classical method attributed to brown bear, but mass spectrometry results show rhinoceros peptide sequences. We have to take these results with great care because most of our sample really lack of collagen. So we need to increase the sample size. And also we realize that we have sampling methods that need to be changed. But however, on the 10 retouchers she studied, she highlighted the 3 main taxa of the assemblage, so brown bear, auroch, and rhinoceros, which seems to indicate an opportunistic choice of the raw material after the marrow extraction. So her work also highlights viability of stigmata that could be induced to individual viability. It seems that there are differences between right-handed people and left-handed people, and also maybe multiple uses of this tool, and this is a lead that we are following. So this preliminary work shows a real interest to combine classical studies with mass spectrometry. The combination of experimental work and traceology allows us to ascertain the use of these tools as retouchers. And we were also able to highlight the preparation of the edge of the lithic tools. So by scratching them in the with the bone tool, in order to make the edges stronger for the retouching. We call that égrésage. We still don't have a word in English, but if anyone has an idea or knows about that, we will be glad to discuss about it. So I am following this work on my thesis, and we plan to study the whole assemblage of Biache-St-Vaast by running more mass spectrometry analysis and to start a larger scale traceology and experimental work with the Liège University. We then plan to apply the same protocol to other sites in order to have an overall view of neonatal behaviors at the scale of Northern France. I thank you for your attention.